Today I want to unpack something something obviously very related to acids and bases, and that is pH. That is what you've always heard about acids and bases. That is the scale that goes from 1 to 14. It is related to the concentration of those H+ ions, which we talked about yesterday. So I want to unpack what exactly pH is, why we use it, what it's useful for, and so on and so forth. So starting with the worksheet from yesterday, as we're all supposed to do this top section here, what numbers did you get? Anybody do this top section on the back?
I thought you were going to explain it.
So, for those of you that did it, remember we started with this equation. H+ ion molarity times OH minus molarity equals 1 times 10 to the negative 14th. To solve this top part, all you had to do was simply substitute in the number that they gave you. And then you would end up with answers that looked like this. So, how that relates to pH is the question for today. These numbers that you see on the board represent the concentration of either H+ or OH-. And if you know either of those things, right, you can solve for the other one. That's what this top section was. It gave you one of them. You just had to figure out the other one. And using this formula, that's really pretty easy. It's x times y equals this, and I give you either x or y. That's the algebra that's involved here. Okay, and again, yesterday we talked about the mix of those things determines whether something is more acidic or more basic. Okay? But ultimately, this is a useful way to describe the concentration of either of these things in your acid or base. But the numbers are kind of awful, right? It's a big scientific notation number. If we wrote this out, it would be 0.00000000267, and that's awful. Right? So what we wanted to do, being chemists, I guess, is make this more palatable. And pH is simply a math trick to make this number easier to use, quite frankly. Okay, and we do that by using logarithms. And now if you remember what logarithms are from, I don't know where you first encountered this in math, Algebra 2 probably? So at this point, most of you should have encountered logarithms. I am not going to reteach what logarithms are, other than to say logarithms are an easier way to express things that are exponents. So then they haven't had it. But suffice to say, logarithms are simply a shortcut or a way to express exponential numbers smaller, I guess, for lack of a better way to put it. This giant awful thing here that many of you will not understand or even recognize is the formula for pH. Now again, this looks awful, and I get that. But this is the formula for how to find pH. And all we need to figure that out is this number, the H+, which we solved for in the homework last night. That's just the molarity, right? The moles per liter of H+ ions in solution. The rest of this, and by rest of this, I mean the negative log part, that's just your calculator does that. And quite frankly, I don't care if you even know what a log is at this point, what a logarithm is. For the purpose of today and what we need to do with pH, you do not need to know what logarithm is. The fundamentals under the hood of it, whatever. That's the math department can teach you that. Okay, but you will need to know how to do this in your calculator. Okay, so let's take our answer for the first question from the homework. That answer was, give me a pen, H plus equaled 1 times 10 to the negative 9th molarity. That was the answer for the first line on your homework. You can check my math on it if you'd like, but that's what the answer is. So now we have our number. Now we just need to plug this into the calculator to solve for pH. Okay? And to do that, you need the button on your calculator called log. So negative log, so you'd hit the negative button. You'd hit the log button. And then you see it gives you an open parenthesis to put something in there. What you're going to put in there is just our number. One EE, what is it? Negative 9. And then you hit enter. Yeah, you close the parentheses at the end. I don't even know if you need to, but you can close the parentheses at the end. pH. What number did you get? Give me the thing. Okay. You added an extra thing in there because you did 1 times 10 e negative 9. It's just 1 e negative 9. That extra 10 is what's throwing it off. So in your calculator, remember how we would write this number would be 1 e negative 9. This is what you should put in your calculator to represent that number. And that's it. So all we did, the whole reason that we did this whole messy thing is just so that we can have nice numbers. That's it. So we could say something has a pH of 3.5 instead of something has a hydronium ion molarity of 2.667 times 10 to the negative 4th. That's it. That's the only reason we did this. To make it nice so you can have this very clean, very easy number that says 9. That's it. It's just a math trick. So let's try another one. Let's go back up to our homework answers. Let's try this one right here. Nope. Because we have a hydronium ion concentration of 4 times 10 to the negative 11th. Right? So let's dump that into our pH calc. So pH equals negative log H plus. So pH equals negative log of 4 times 10 to the negative 11th. And now I'm going to dump that into my calculator. Negative log button. 4e negative 11, close paren. Let's just do 10.4. That's it. That looked pretty easy, right? It's literally just dumping something into your calculator. Your calculator is doing the hard work, and all you're doing is solving for pH. Now, if you were given this, can I solve for pH using just that? No, why not? Yeah, do I have a way to convert something like this to something like this. Yes, that's actually listed on the problem. But also, if you had that number, could you get back to that other number? Sure, because we know hydronium times hydroxide equals 1 times 10 to the negative 14th. And again, I hate to get deeper into the math here, but this is what science kind of becomes, is a lot of math. There's a lot of, well, there's a theory behind this. What exactly are we talking about here? Well, we're talking about the concentration of H plus ions. Okay, good. That's what we're talking about. But how to solve for that, how to make that meaningful, is going to require some math skills. Okay, and part of the math skills is, actually, before you even get to the math skills, it's knowing what equation to use. Like if I know I have this and I'm trying to get to pH, part of that is knowing, hey, I've got to go here first, get a hydronium ion concentration, an H plus concentration first, get that molarity number, then I can just literally plug that into my calculator. But you kind of have to see that journey. And this is where a lot of the science, as we get down to the very end of this class, right? We've done all this chemistry so far this year. And now we get down to something like this where, well, now we kind of have to use what we're doing. And again, this goes all the way back to T-charts, right? If you had to convert some number of, I don't know, kilometers to inches, right? Do you guys know off the top of your hand how many inches are in a kilometer? I don't either. But could I do that conversion, do you think? Could I? Me? Why? Well, it's a T-chart, but what do I also know to go from kilometers to inches? Yeah, inches to feet, feet to miles, whatever it is. I know all of those different conversions, and I can figure out how to get there. It's just going from one to another, and getting into that thing. So yeah, I have no idea how many inches are in a kilometer. I have no idea. But I know how many inches. I know a conversion between centimeters and inches, and I know a conversion between centimeters and meters, and I know a conversion between meters and kilometers. So yes, with a T-chart, I could figure that out. This is kind of the same thing where, well, if I have this, can I get to pH? Well, yeah, but I need to go from here, right? I'll probably have to come back up here to solve for this. And then once I have this, then I can come over here and plug it into this. And that's where it becomes more of a journey, right, than knowing specifically how to exactly do that. Right? There's 2 steps involved. On the quiz on, what was it, Monday? The gas laws quiz. I looked through some of those. We're going to talk more about this either tomorrow or Friday, but they were a train wreck. And as happens with a train wreck, I had trouble looking away. They were bad. And I don't get it, because it's really, to me, gas laws is just some simple math stuff. I mean, it is multiplying and dividing stuff. This is even harder than that. My gosh, this is a button I've never seen on my calculator. So, anyway, one last thing about this is what happens if we want to go the other way? What is the molarity in a acid with a pH of, I don't know, pick a number, 4.7, question mark. So with this, you would go the other way in your calculator. You would have that log button. You're going to hit second. Right? You guys have this button on your calculator? What am I doing here? Get rid of this. You're going to hit the second button. That's going to give you a little, and then hit log. That gives you a little this. Do that now on your calculator if you haven't yet. Hit second and then log. You get a 10 with a little box that's blinking for those of you with these sorts of calculators. And in that box, you literally just put the negative pH. And you get some number. I'm going to round this up. So again, logarithms have to do with exponents. And in this case, you're raising 10, because it's log base 10, to some exponent. Now, the weird thing here is what you're really doing is raising a number to what is possibly a decimal exponent, which is kind of meaningless in hand calcs. Like if I gave you a piece of paper and I said, hey, what is 7 raised to the power of 3.2? Are you going to have a good time with that? I'm not either, right? But that's essentially what we're saying here. That's where logarithms are something. It's 10 to the something, but it's it can be a decimal value. So again, you need your calculator, and then you can just figure that out. Any questions on this? All right, for homework, all we're doing is this second brick of problems. I'm going to have a worksheet later this week that's a little bit better. I didn't want to get into all the rest of this. There's also a thing called POH, which is just like pH, only it uses the hydroxide ion, and it's a little bit more messy than what we want to get into. So we're just going to stick to pH and H plus molarity for now. So that's just the second grouping of these on the sheet. We're good.